Our fourth valid deductive pattern is called the disjunctive syllogism. Okay, you might notice this one starts off a little differently. It doesn't start off with an if-then statement. It starts off with a disjunction, or an or statement. Our first premise is that either P or Q is true. Our second premise is that P is not true. The conclusion, then, is that Q must be true. Think of this as a simple process of elimination. Remember what P or Q means. It means that at least one of these two things has to be true. If we then learn in the second premise that P is false, well, by process of elimination, Q has to be the case, right? So, we're getting used to seeing P's and Q's in more complicated situations. Here's another example of the disjunctive syllogism. We have a disjunction, we have an or statement. And this statement tells me that either A and B is the case, or C is the case. In premise 2, I then learned that, well, it's not true that A and B is the case. So by process of elimination, C must be the case, right? So think of this as the sort of thing you do all the time when you eliminate one option and draw a certain conclusion about the other option. Let's say, for example, you know that the problem with your computer has to be the screen or the battery. If you know that for certain, and then you're able to establish that the problem is not the screen, well, you can conclude with certainty that the problem with your computer is the battery. That's the power of the disjunctive syllogism. Here's another example. Once again, we start with a disjunction. We start with an or statement. And this premise tells us that either this is true or this is true. We then learn in the second premise that the first option is not the case. It's not the case, A, if and only if B. Therefore, we can conclude that it must be the case that E or F is true. So the disjunctive syllogism can take any disjunction, any or statement, and tell you that one of the two has to be true if the other is false. Let's use it in a proof. Let's say your goal is to establish B. Based on the information you're given, you need to establish that B must be the case. Well, you can do that now using some of our rules. Let's start practicing thinking backwards. If we're looking for B, we might ask ourselves, what would we have to establish in order to establish B? Well, notice that B appears in line 1. Right? And line 1 tells us that if either A or B is true. If we could establish that A was not the case, then we could use the disjunctive syllogism to conclude that B is the case. How could we possibly conclude, then, that A is not the case? Well, look at these two. Line 2 tells me that A implies C. Line 3 tells me that C is not the case. Well, if I put these two together, what am I going to get? I'm going to get not A, because of our second rule, modus tollens, on lines 2 and 3. And now I can use our new rule, the disjunctive syllogism. Line 1 tells me A or B is true. Line 4, I've just added, tells me that A is not the case. What does that mean? B must be true. This is the disjunctive syllogism on lines 1 and 4. The good news about these proofs is that they're all rigged. They all work, right? The answer is always buried in the premises. Your job is to draw information out of the premises and add to that information until you can explain to me why this must be true. This is the disjunctive syllogism.